I'm Estiven Martinez, and this is my AP Problem 2. So the given information is a 0.150 gram sample of solid lead 2 nitrate is added to 125 milliliters of 0.100 molarity sodium iodide solution. Assume no change in volume of the solution. The chemical reaction that was given to us was PbNO32 plus 2NaI produces PbI2 plus 2NaNO3. Alright, so for A, we have to list an appropriate observation that provides evidence of a chemical reaction between the two compounds. So, an observation is that there is a different precipitate formed in the solution than when we started, because we started with PbNO32 as our solid, and we ended with PbI2 as our solid. So there was a different precipitate at the end of the reaction. For B, we need to calculate the moles of each reactant. So, we take 0.150 grams of PbNO32 and divide it by the molar mass of PbNO32, which is 331.3 grams, and we get 0.000453 or 4.53 times 10 to the negative 4 moles of PbNO32. To calculate the moles of NaI, we need to use the equation volume times molarity equals moles. So we divide 125 milliliters of NaI by 1000 to get 0.125 liters of NaI, and we multiply that by the molarity of NaI, which is 0.1, and we get 0.0125 moles of sodium iodide. For C, we must identify the limiting reactant. For every mole of PbNO32, there's 2 moles of NaI. So we multiply the moles of PbNO32, which is 4.53 times 10 to the negative 4 moles, and we multiply it by 2 to get 9.06 times 10 to the negative 4 moles of Ni reacted in the reaction. So PbNO32 is a limiting reactant because there was 0.0125 moles of sodium iodide, but we only used 9.06 times 10 to the negative 4th power moles of sodium iodide. For D, we need to calculate the molar concentration of NO3- aqueous in the mixture after the reaction is complete. We take the moles of PbNO32, which is 4.53 times 10 to the negative 4 moles, and we do the molar ratio of PbNO32 and NaNO3. For every mole of PbNO32, there are 2 moles of NaNO3, so the molar ratio is 2 to 1. We multiply by 4.53 times 10 to the negative 4th moles of PbNO3 by 2, and we get 9.06 times 10 to the negative 4th moles of NO3- aqueous. Then we divide the moles of NO3- by the volume of the solution, which is 0.125 liters, and we get a molarity of 7.25 times 10 to the negative 3rd power for NO3. For E, we have to circle the mixture that best represents the results after the mixture reacts as completely as possible. So I chose this mixture because PbI2 was the solid, and since PbNO3 was the limiting reactant, there are iodine and sodium ions in the mixture. Also, since there was less moles of lead than NO3, then there should be some NO3 ions in the mixture, and there's one in there. Also, so the only one that met these requirements was this beaker, so this is why I chose this beaker for my answer.